Now you'll notice I actually went to a very different scale from what I've been using before. It's because of the kind of asymptote I've got. The asymptote is x plus 7, so it's already going to be quite high. It's going to be going like this. So I wanted to make sure I had enough room there for it. So what do we know? The y-intercept is 4 1/3. So that's going to be pretty much there. 0, 4 1/3. The x-intercepts were just below -6 and just above 2. Just below -6. So that was, what was it exactly? -2 minus root 17. And just above 2, which was, I've run out of room to label things, haven't I? This one was -2 plus root 17, 0. What else do I know? I have a vertical asymptote at x equals 3. Now my special other asymptote was y equals x plus 7. So that's a diagonal line, but going through 7. Oh, I should probably label those. X equals 3 and y equals x plus 7. Now here's the challenge. How do I connect up the graph to make that work? It crosses the x-axis here and the y-axis there, and it never crosses this asymptote or this one. Well, that means my graph has to be coming up pretty close to there, pretty close to that asymptote. It's going to loop around here somewhere and go back down towards this one. And the rest of the graph is going to be up here on this side of this asymptote. Now the exact shape is going to be pretty much the same as this one. So we're going to come down here, we're going to come into about here, down to here, and back up very close to that asymptote. And that was, not going to fit my equation there, let me write it down here instead. Y equals x squared plus 4x minus 13 over x minus 3. Now if you wanted to, you could plug in x equals 5 or x equals 7 or 7.5 into this function to work out the exact value here. I'm not going to bother. Feel free to go ahead and then tell me how wrong my diagram is.